Hi students, welcome to today's class. So today also I will continue the chapter Binomial Theorem. So very useful for your JEE mains examinations which is going to held in this month. So definitely you are going to get one question from this Binomial Theorem. So to solve that problem, so what you need is you should have a fundamental grip over all the formulae. So binomial theorem is nothing but formulae. So list of formulae. So if you remember the formulae, correct formulae at correct time, so you will get the solution for the problem. Okay. So in today's class, I am going to explain the analysis of binomial expansion. Okay. So what is analysis of binomial expansion? Let us see. First, let us see the expansion of x plus y whole power n, where n is a natural number or positive integer. We can write it as a z plus or n belongs to n, natural number or positive integer. Positive integer means natural number. That means n is equal to 1, 2, 3, 4, 5, 6 like that. Okay, now. So let us see that expansion. We know the formula nc0 x power n plus nc1 into x power n minus 1 into y plus nc2 into x power n minus 2 into y square plus so on. General term ncr into x power n minus r into y power 1 r plus so on ncn into y power n. Understand? So there are n plus 1 terms are there. So this is called binomial expansion. The formula given by is Newton. So now what I am going to do is, let us put here x and y are variables. We can put any values. Let us put x is equal to y is equal to 1. Let us substitute x is equal to 1, y is equal to 1. What happens here? 1 plus 1 is equal to 2 power n. So here 1 power n minus 1 into 1. So all x and y terms will go. Only the binomial coefficients remains. That means nc0 plus nc1 plus nc2 plus so on ncr plus so on ncn is equal to 1 plus 1 to 2 to the power of n. So this is a one formula. This is called sum of the binomial coefficients. So this is one of the formula, sum of the binomial coefficients, nc0 plus nc1 plus nc2 plus ncr so on ncn is equal to 2 to the power of n. From this concept, immediately we can get a conclusion that, so if you want to find out the sum of the binomial coefficients in any binomial expansion, the simple thing is substitute x is equal to y is equal to 1. For example, what is sum of the binomial coefficients? See here, this is called binomial coefficients. What is the sum of the binomial coefficients? So in the expansion of 3x square minus 2xy whole to the power of 20. So in this expansion, there are 21 terms will be there. 21 terms will be there. So if you want to find out the sum of the binomial coefficients, simply put x is equal to y is equal to 1. Now substitute there. So if you substitute, what happens? So this is equal to 3 into 1 square, 2 into 1 into 1, 2 to the power of 1, 3 minus 2, 1, 1 to the power of 20 is equal to 1. So sum of the binomial coefficients is equal to 1. That is the thing you have to get. So anything, in any expansion, whatever may be the expansion, if you want to find out sum of the binomial coefficients, put x is equal to y is equal to 1. So this is a one short trick method. Okay, now let us see one more result here. So this is our first result. Now coming to the second result, if you put x is equal to 1 and y is equal to minus 1, let us see what happens. If you put x is equal to 1, y is equal to minus 1, see what happens. Here x value is 1, y value is minus 1. 1 minus 1, 0. 0 to the power of n, 0. Now if you observe here, depending upon the 1 power 1, 1 power n, 1. Here y value is minus 1. So here minus will come. So from this what you will get? So this is equal to nc0 minus nc1 plus NC2 minus NC3 plus NC4 plus so on minus, see here, general term. Here we don't know in the middle term which will come positive and either it will maybe a positive, maybe negative, that depends upon the n value. So that's why minus 1 whole power r NCR plus last term also minus 1 whole power n into NCN. This value is given by 0. Understand? So if you put x is equal to 1, y is equal to minus 1. Now what I am going to do is regroup the terms, grouping the remaining terms. Why? Because see here NC0, NC2, NC4. See the suffix here 0, 2, 4. So bring all the terms one place. So this is equal to NC0 plus NC2 plus so on NC4 plus so on. Last term we don't know. Minus, minus, minus. Take minus common outside. So minus of NC1 plus NC3 plus NC5 plus so on. This is equal to 0. This is equal to 0. Okay now? Right. Let us continue the class. Now let us take these minus terms to right hand side. Let us see the sum of the binomial coefficients of even suffixes. So 0, 2, 4. So and again we will see the sum of the binomial coefficients of odd suffixes 1, 3, 5, so on. Okay na? So let us continue the class. Welcome back. So now we got the result here, NC0 plus NC2 plus NC4 so on is equal to NC1 plus NC3 plus NC4 so on. This sum is nothing but the total sum is equal to 2 to the power of n. Already we have that NC0 plus NC1 plus NC2 plus NC3 plus so on, last one is NCN. This sum is equal to 2 to the power of n. This sum is equal to 2 to the power of n. So if you observe here NC0, NC2, NC4, these are the half of the terms, and then NC1, NC3 so on, NCN is the remaining half of the term. That means what? The sum is equal to, it will become half. This here one logic is here. What that logic is, NC n is equal to NC n minus r. Formula is there. That means here 6C2 value is same as 6C4 value. Understand? 6C2 value is 6C4 value. 6C5 value is same as 6C1 value. 6C5 is and same as 6C1. Like that both the sums will become equal, and the two equal parts become half of the total sum. Therefore, so NC0 plus NC4 plus NC2 plus NC4 plus so on is equal to NC1 plus NC3 plus NC5 plus so on is equal to 2 power n by 2, 2 power n minus 1. Understand this? 2 power n minus 1. Okay. So from this we will get a conclusion. What is the conclusion is, for example, what is the value of n plus C1 0, n plus 1 C2, n plus 1 C4, so on. What is this sum here? N plus 1 C0, n plus 1 C2. So here in place of n simply substitute n plus 1. That is equal to 2 to the power of n plus 1 minus 1. This is nothing but 2 power n. Understand? So if you want to find out n plus 1 C0, n plus 1, sorry, otherwise 1, n plus 1 C3, n plus n minus 1 C3, n minus 1 C5 plus so on. This can be written as, wherever n is there, substitute n minus 1. So 2 to the power of n minus 1 minus 1, 2 to the power of n minus 2. In place of n, substitute n minus 1. So in place of n, substitute n minus 1 minus 1. 2 to the power of n minus 2 will be your answer. Okay. So now if you want to know these two results, the fundamental result is this. The fundamental result is this. If you know this result, cyclic order, you can find out the sum of any binomial coefficients. Okay now. So I hope that you understand this concept. So let us go for next concept. So basing on the concepts that we learned here, let us find the sum of these expression, sum of this expression. Let us see this solution. Let this be a sum of this. This is a 1 by 1 factorial into n minus 1 factorial, 1 by 3 factorial into n minus 3 factorial, plus 1 by 5 factorial into n minus 5 factorial, plus so on. 1 by 5 factorial into n minus 5 factorial, so on. Now what I am going to do is how to do this problem. See here, immediately 3 factorial n minus 3 factorial. So you have to get an idea of NCR formula. So what is NCR? So this is n factorial by n minus r factorial into r factorial. Understand here. So here in the numerator n factorial by n minus r factorial into r factorial. If it is there, we can write down it as a NCR. We can write it as a NCR. But in the numerator, so here n factorial by n minus 3 factorial into 3 factorial. Here n factorial is not there. N factorial by n minus 5 factorial into 5 factorial. In the numerator, n factorial is not there. That's why multiply the numerator with each term with n factorial, so that we have to divide with n factorial. Therefore, s by 1 by n factorial into multiply. So, I have divided n factorial. So, multiply each term with n factorial. So, this is equal to n factorial by n minus 1 factorial into 1 factorial plus n factorial by n minus 3 factorial into 3 factorial plus n factorial by n minus 5 factorial into 5 factorial plus so on. Okay, now, right. So, this implies s is equal to 1 by n factorial. So, n factorial by n minus 1 factorial into 1 factorial. So, this is equal to nc1 plus nc3 plus nc5 plus so on. Understand this? So, this already we know nc1 plus nc3 plus nc5, already we know that. So, the formula is s is equal to 1 by n factorial into, this is given by the formula 2 to the power of n minus 1. Understand this? So, therefore, so your answer is equal to 2 to the power of n minus 1 by n factorial. So, this is the sum of the given terms. Okay, now. So, to solve this problem, the first idea that you have to get is by seeing the denominator. So, it is in the form of n minus r factorial into r factorial. So, if it is in the numerator, n factorial is there, the problem you will get. After this, nc1 plus nc3 plus nc5, sum of the binomial coefficients with the odd suffix. Okay, so that is equal to 2 power n minus 1. So, this is the sum. Okay, now. So, let us see one more problem, okay, basing on the what are the concepts that we learned. Okay, now. Welcome back here. Let us see one more problem. Here it is given, find the sum of sigma k runs from 0 to 10, 20 ck. So, it is seeing that a very simple problem. Let us see that. Solution. Let this sum be sigma k runs from 0 to 10, 20 ck. Okay. So, let us expand this. So, this is equal to 20 c0 plus 20 c1, 20 c2 plus so on 20 c10, 20 c10. See, the options are 2 power 19 minus 1 by 2 into 20 c10, 2 power 18 minus 1 by 2 into 20 c10, like that different answers are there. Then how to do? So, 20 c0, 20 c1, 20 c2, shall we find out all the values? We know the short trick method, how to find out 20 c2 value, 20 c3 value. So, if you go on start doing the problem, it takes almost 20 to 30 minutes it takes to solve those problems. Okay, now. Then how to do this type of problem? So, then how to do? Okay, now. So, let us do this problem like this. Right. So, let us see this solution. So, what we will do? We know that 20 c0 plus 20 c1, 20 c2, so 20 c3 plus so on 20 c10. Understand? So, here 0, 1, 2, 3, so on 10. So, NCR. So, here we know that NC0 plus NC1. So, NC. So, 20 C20 up to 20, no problem. So, this is equal to, so NC0 plus NC1 plus NC2 plus so on NCN is equal to 2 to the power of n. Sum of all the binomial, that is a 2 to the power of 20, we know that. So this is the result, we know that. Understand this. Okay. So we know that 20C0 plus 20C1, 20C2, so on, sum of the binomial coefficients of 20C, NCN is equal to 2 to the power of n, here 2 to the power of 20. Now here what we are want to do is, here total how many terms are there? 21 terms are there, 21 terms. We know the formula NCR is equal to NCN minus R, NCR is equal to NCN minus R. Now what we are going to do is 20C0 value plus 20C19 value same. Why? Because 20C0 value, 20C20 value is same. 20C0 value plus 20C20 value is same. I will group it together. Next one, 20C1 value, 20C19 value same. 20C1 value, 20C19 value same. Why? Because 1 plus 19 is equal to 20. So if you go on writing, so last one, so what you will get? 20C9 value plus 20C11 value same. Why? Because 9 plus 11, 20. What is the term remains means 20C10 value remains. This is equal to 2 power n. Okay now. So altogether see here 0, 1, so on 9 plus, so here those 9 plus 9, 18. So altogether, so how many terms you will get? 0, 1, so on 9. That means 10. 10 plus 10, 20, 20 plus 1, 21 terms are there. Now see here, 20C0 value plus 20C, all together there are how many terms are there? 10 terms are there. 10 terms are there. So we can write it as so this is equal to 2 times. Why? Because these two sums are same. These two numbers are same. These two sums are same. That is a 2 times 20C0 plus 20C0 plus 20C1 plus 20C2 plus so on 20C9. This is the sum is equal to plus 20C10 is equal to 2 to the power of n. 2 to the power of n means here 20. 2 to the power of 20. Understand? Now what we are going to do is first to take this 20C10 to right hand side. So this is a 2 times a 20C0 plus 20C1, 20C2 plus so on 20C9 is equal to 2 power 20 minus 20C10. 20C10 value I have taken to that side. Okay now. Now what I am going to do, take this 2 also to that side. 2 also to that side. So this is equal to 20C0 plus 20C1, 20C2 plus so on 20C9 is equal to 1 by 2. Otherwise you can write it as a 2 power 20 by 2 minus 1 by 2 into 20C10. But we have to find out the sum up to 20C0, 20C1, 20C2, 20C9 only we have taken. Okay now? 10. So 0, 1, 2, so on 9 means these are 10 terms are there. Okay? 10 terms are there. So it is the sum of 11 terms, but it is a sum of 10 terms only get. So we want 20C10. So add 20C10 on both sides. So if you add 20C10 add on both sides. So 20C10 add it on both sides. So this is given by the 2 to the power of 19. So 2 to the power of 20 by 2, 2 to the power of 19. So minus 1 by 2 20C10 plus 20C10 is equal to plus. So this is a 1 by 2 20C10. 1 by 2 20C10. Therefore, option C will be the correct answer. Okay now, right. So very nice problem this is a. So this is the thing. We have to know the fundamental concept. If you know that, the answer will be very, very easy. Okay, now. So I hope that you understand this solution. Let us go for next concept. Hi students, welcome back to this concept. Now we are going to see the middle term or middle terms. What is the meaning of this middle term or middle terms means? See here, if you see the expansion of x plus y whole power swan number we will take 3. If you take the x plus y whole power, x plus y whole cube, so the total number of terms are 4. That is, let us call it as a t1, t2, t3, t4. 4 terms you will get. In these 4 terms, what will be the middle terms? So t2 and t3 will be the middle terms. Okay, that means if the power is odd, that is the index, the binomial index is odd, you are getting 2 middle terms. Okay, so if it is a even, for example, x plus y whole to the power of 4, let us see that t1 plus t2 plus t3 plus t4 plus t5. How many terms will be there? 5 terms. If it is a 4, you will get 5 terms. If it is a n, you will get n plus 1 terms. Then what will be the middle term? So the middle term is exactly 1 and only 1 term you will get. So from this example, so what is the conclusion we will get? So if the power is odd, there are 2 middle terms. If the power is even, there is only 1 middle term. Okay, now. So that whole depends upon the power of the binomial or index of the binomial. So now we are going to get this step. So this is for example, like that you remember, in a flow chart way you remember, x plus y whole power n. Here n belongs to natural number, positive integer. So here there are 2 cases arises. The first case is n is even. The second case is n is odd. N is odd. Okay, if n is even, you will get a 1 and only 1 middle term. That is given by t of n by 2 plus 1. T of n by 2 plus 1. So that means here in place of n, substitute here 4. 4 by 2, 2. 2 plus 1, 3. Third term will be the middle term. Okay, now, right. If n is odd, you will get 2 middle terms. One is t of n plus 1 by 2. Another one is t of n plus 3 by 2. Understand? What is n plus 1? For example, see here 3. Substitute here 3 plus 1. 4. 4 by 2, 2. 3 plus 3, 6. 6 by 2, 3. Third term. That means second term and third term will be the middle term. If it is n is even, there is 1 and only 1 middle term. If n is odd, there will be 2 middle terms. Okay, now. Then how to remember? Very easy. N is even, no? That's why it can be divisible by 2. Therefore, n by 2 plus 1. If n is odd, it cannot be divisible by 2. That's why n plus 1 by 2. Next number, how you will get? Very simple. Next term. That means if it is second term, third term. Fourth term, next term is fifth term. That's why plus 1 you add it here. That means simply you add plus 1 here. N plus 1 by 2 plus 1, that is equal to n plus 3 by 2. Next term, n plus 3 by 2. Understand this? So this is the concept between this middle term or terms. Depending upon the n value, you will get the number of middle terms. Okay, that's all. Okay, I hope that you understand this concept. Welcome to this concept. Now we are going to see greatest binomial coefficients. See here, binomial coefficients, not simply coefficients. See, remember here, in the binomial coefficient and coefficient, both are different. For example, if you take this some 3x square minus 5 whole to the power of 5, 3x square minus 5 whole to the power of 5. So here what is, you will get 5c0 3x square whole to the power of 5 plus 5c1 3x square whole to the power of 4 into y minus 5. Of course, you will get a minus here, plus 5c2 3x square whole power 5 minus 2 ncr x to the power of r minus plus nc1 into x to the power of n minus 1 into r. So 5 minus 2, 3 into y square plus so on. Last term 5c5 y to the power of 5. Of course, you will get minus here. Why? Because here 5 is odd number, right? In this 5c0, 5c1, so this is there now 5c0, 5c1 plus 5c1 including sign plus 5c1 plus 5c3 minus, they are called binomial coefficients. They are called binomial coefficients. General coefficients, how we will get? So here 5c0 is 1, so 3 to the power of 5 into x to the power of 10. This is a 5c1 into 3 power 27. So into x to the power of 8. If you multiply this, this is coefficient, simply coefficient. 5c1 is 5, 527 if you multiply. So that is the coefficient. If you are asked to find out the binomial coefficient, greatest binomial coefficients, then 5c0 minus 5c1, 5c2, 5c3. They are the greatest binomial coefficient. Those are the binomial coefficients. Now our concept is, what is greatest binomial coefficient? Okay, now, so where it will get? So let us see this. For example, so this is there 3x square plus y whole to the power of some 4 is there, 4. So what are the binomial coefficients here? What you will get? 5c0, 5c1, 5c2, 5c3, sorry 4c1, 4c0, 4c1, 4c2, 4c3, 4c4. Those are the binomial coefficients. In this, you know that 4c0 value is 1, 4c1 value is 4, 4c2 value is 6, 4c3 value is 1. So this is a 4c1 value is 1. Which is the greatest binomial coefficient? That is the 6, nothing but 4c2. If you observe here, 4c2 is the middle term. 4c2 is the middle term. So from this we can conclude, for example, even though it is odd, the same concept applies. 3x square plus 4 to the power of 5 is there. So this is a 5c0. So I will write down directly values. 5c0 value 1, 5c5 10, 5c2 10, 5c3 also 10, 5c4 5c5. So here what are the binomial, greatest binomial coefficient here? 10 and 10. So these are nothing but middle terms. Nothing but this is also middle term. From this example, we conclude that the greatest binomial coefficients is nothing but the coefficient of middle term. Understand? The coefficient of middle term. So whatever may be the middle term is there, its coefficient is the greatest binomial coefficient. Okay, now then how to find out? What is the formula for this? Is any direct formula is there? Yes, it is a formula is there. Let us see that formula. So welcome back. See here, I am going to write the greatest binomial coefficients. You remember the formulas like this so that it will be very easy to remember. X plus y whole power n. So there are two cases arises. Here n is a natural number. So when n is a natural number, if n is a even, so therefore there will be odd number of terms. There will be one and only one binomial, greatest binomial coefficient. So that is given by nc n by 2. So this is the greatest binomial coefficient. N is even, no? Even by 2. You can divide easily. If it is odd, n is odd. Therefore, n is odd means you will get an even number of terms. So there will be two middlemost terms. Both are greatest and both have the same equal value. So that is given by nc n minus 1 by 2 and nc add plus 1. You just add plus 1. So that is equal to n plus 1 by 2. So plus if you add it n plus 1 by 2. So these two are the greatest binomial. Both are same answers you will get. Both same answers you will get. Those two are the greatest binomial coefficients. This is nc n by 2. If it is n is a even, odd number of terms will be there. There will be one and only one middle term. Its coefficient is nc n by 2. If n is odd, then there will be even number of terms will be there. There will be two middlemost terms will be there. Their coefficients are, binomial coefficients are this. Okay, now, right? I hope that you understand this concept. Basing on this, there is a very nice formula, problem is there. Let us see that problem. Dear students, welcome to this problem. So very nice small problem here. So let us see the problem. If the coefficient of the middle term in the expansion of 1 plus x whole to the power of 2n plus 2 is alpha, and the coefficient of middle terms in the expansion of 1 plus x whole to the power of 2n plus 1 are beta and gamma, then the relation between alpha, beta, gamma is. Here altogether there are two binomial expansions are there. So one is first one 1 plus x whole to the power of 2n plus 2. Another one is 1 plus x whole to the power of 2n plus 1. Observe here, this is a even number 2n plus 2. For all values of n is a natural number, 2n plus 2 is a even number. 2n plus 1 is obviously an odd number. For an even number, there are odd number of terms will be there. There are 1 and 1 term will be the middle term. So what is the coefficient we have? Already I explained the just now concept, nc n by 2. nc n by 2. Understand? So here also the coefficient that is given as alpha. Alpha is given as a 2n plus 2c 2n plus 2 by 2. That is a 2n plus 2c n plus 1. So this is the 2n plus 2c n plus 1. So that is the alpha value. Okay, now coming to here, 2n plus 1 is a odd number. So what is the binomial coefficient we have? nc n minus 1 by 2 plus 1. Next one, that is a, let us call it as a beta. Beta is nc n minus 1. That is a 2n plus 1 minus 1 by 2. That is a nc plus 1 minus cancel, 2 also cancel. Sorry, here 2n plus 1. 2n plus 1 c, 2n plus 1 c, n you will get 2n plus 1 c n. Next gamma is equal to nc. Next term is what I have taken, nc n plus 1 by 2. Next term. Now here 2n plus 1. So here 2n plus 1. 2n plus 1, this is we call it as gamma. 2n plus c, c. 2n plus 1 by 2. So this is a 2n plus 1 c. So here you add it 2n plus 2, 2 can cancel. Here n plus 1. Okay now. So we will get here n plus 1. So altogether, so see here, this is your alpha value and it is your beta value and it is your gamma value. Then what is the relation you will get here? We have a formula here in permutations and combinations. What the formula is, ncr plus ncr minus 1 is equal to n plus 1 cr. So this is the formula we have. ncr plus ncr minus 1 is equal to n plus 1 cr. Understand? So n you have to add n plus 1 r minus 1. Consecutive number should be there. So whatever may be the bigger c. Observe here beta plus gamma. Write the value of beta plus gamma. So beta plus gamma is equal to 2n plus 1 cn plus 2n plus 1 cn plus 1. It is given as ncr plus ncr minus 1 is equal to n plus 1 cr. So here 2n plus 1 cn plus 2n plus 1 c is equal to 2n plus 1 plus 1. So you have to add one thing, 2n plus 2 c, whichever is the bigger, n plus 1, which is the bigger one, n plus 1. Nothing but gamma, 2n plus 2 c n plus 1. That means what is the relation between alpha, beta, gamma is equal to, what is the relation between alpha, beta, gamma? So beta plus gamma is nothing but alpha. So this is nothing but alpha. Beta plus gamma is equal to alpha. That is the relation between alpha, beta, gamma. So to know this formula, so you have to know this binomial coefficients. Okay, now, dear students, I hope that you enjoyed today's class with some more problems and some more topics. In the tomorrow's class, I will stand before you. Until then, all the best.